Yeah, good morning, students. In this video, I will be discussing on two important topics. One is IPv4 address space, and the other one is notations of IP version 4. First, let us see the address space of IPv4. An Internet Protocol version 4 address is a 32-bit address that uniquely and universally defines the connection of a device to the Internet. It means any system, if it wants to communicate in an Internet, it should have a unique IPv4 32-bit address, or it should have IPv6 128-bit address. So based upon the number of bits, we can easily identify the address space. So the address space of IPv4 is 2 power n, where n is nothing but 32. So 2 power 32 will be the address space for IP version 4. So this much. Similarly, if you are using IPv6, then the address IPv6 address will be 128-bit, and the corresponding address space will be 2 power 128. Means these many number of systems we can connect using IPv4 and IPv6. Okay. Next, we will see the notations of IPv4. So IPv4 can be represented in two notations, either in binary form or in dotted decimal notation. So, but keep in mind the size of an IPv4 is 32 bits. Okay. Now let us see the binary and dotted decimal notation. So this is nothing but binary notation. Normally, the IPv4 we already discussed in our previous videos regarding how to represent IPv4. It is represented in 4 blocks. This is block 1, block 2, block 3, and block 4. Each block is separated by dot. Okay, and each block will have 8 bits. So 2 power 8 is nothing but 256. So the range will be from 0 to 255. So within those values, we can write any value. This is what 128.11.3.31. So this is one of the valid IP address which is represented in dotted decimal form. So if you want to convert this binary number into decimal number, then it becomes into binary number, then it becomes a binary notation. So 128 you just represented using 8 bits. So it is nothing but 1000000. Similarly, 11 using 8 bits 00001011. Similarly, 3 like this and 31 like this. So this is nothing but your binary notation. But please see that there is no dot separated in binary notation form. Only in decimal form it should be separated by a dot. So this is what we call it as decimal notation, and this is nothing but your binary notation. Hope so understood. So same thing is written here in binary notation. The IPv4 address is displayed as a 32-bit. This is what 32-bit. Each block consists of 8 bits. 8 into 4, 32. So each octet is often referred to as a byte. So this is nothing but a byte, where it consists of 8 bits. So an IPv4 address is a 32-bit address or a 4-byte address. Yeah, that is it. And as I told you, the decimal form is represented by a dotted decimal form, where each dot separates the bytes. So this is 1 byte. So totally there are 4 bytes. So hope you understood. Now let us see one small example. You can take it as assignment. Change the following IPv4 address from binary notation to dotted decimal notation. So this is in binary form, which is of 8 bits each block, and there are totally 4 blocks. So try to convert this into decimal notation. You know, I think how to convert. For example, I will take 1. I will take this block 11101 1 1 1. Just to write like wherever there is a 1, 2 power 0 plus 2 power 1. This is 2 power 2. This is 2 power 3. 0 means we can neglect, and 2 power 4 and 2 power 5. So like that, wherever there are ones, convert it into binary to decimal by using 2 power 0 1 like that. Okay. So here is the example. So you will convert this if you will get 239. So if you try this one, like this is 1 is there now, so 2 power 0 plus this one is also 1, 2 power 1 plus 0 you will of 2 power 2, then 1 is 2 power 3. So remaining all zeros we can just neglect it. So 2 power 0 is nothing but 1 plus 2 power 1 is nothing but 2 plus 2 power 3 is nothing but 8. So 8 plus 2 plus 1 is 11. So this is what 11. Similarly, you can convert this into decimal and this into decimal. So same thing you can do for this also. So this is how you are going to convert binary notation into decimal notation. Similarly, you can do vice versa. So change the following IPv4 address from dotted decimal notation to binary form. So just you can represent each one into 8 bits. So 111, you just convert it into binary form with 8 bits. So this is what you will get. 0110 1111. Similarly, 56 can be replaced with 0011 1000. 45 is nothing but this one, and 78 is nothing but this one. But please keep in mind, don't put a dot for each byte, okay, in binary form. So this is how you need to convert the decimal notation into binary notation. So one more example also we have. Find the error if any in the following IP address. Yeah. Can you find any error in this IP address? Please check 111.56.045.78. Yes. You should not represent a single byte in both binary and decimal notation. So if you put 0 before 45, it is invalid. It should contain only 45. There should be no prefix of 0. It thinks in a mistake, it is binary form. Okay. And the second one, 221.34.7.8.20. Yeah, this is also some error because any IPv4 address will have only 4 bytes of address, means 4 blocks. Here it's having 5 blocks. 1, 2, 3, 4, 5. It is invalid. 75.45.3.1.14. Yes, this is also error because the third byte is having 301, which is invalid input. For example, each block may contain maximum 8 bits. 2 power 8 is 256. So the range will be from 0 to 255, but it is having 301, which is impossible. So it is invalid. And 111 something dot 23.14.61. It is also invalid because any IP address can't be represented both with binary form as well as decimal form. So in this way, we can just identify uh, the errors and we can practice. So here is the solution also available for the above question. Okay. So this is what something about IPv4 address space and also the notations of IPv4, that is the binary notation as well as dotted decimal notation, and also a few examples to identify the error in the IP address. Hope so enjoyed the video. Thanks for watching and subscribe my YouTube channel for more videos. Bye.